Well, good afternoon, everybody. Welcome to chemistry. Okay, I'm Dr. Fred. I'll be your instructor for the summer. So I get to torture you for the next 8 weeks. Okay, first things first, I need to do a roll call. So if you would, if I call your name, type in the chat, down in the chat, type your full name, please. So that's record that you are here the first day. I'm required to make sure that, you know, if you're not here the first day, I gotta cut you, and I don't want to do that. All right, so once I call your name, please type in your name down in the chat. So I got, and if I mispronounce your name, my apologies. Callahan, excuse me. Are you here today? Bauer, B-A-U-E-R, Bauer, I don't see you. Okay. How about Danny? Danny, you here today? Okay, Danny, are we here? All right, Danny, got you there. All right, got your name typed in there. That'll work. Yeah, type your name in there. Give me your full name there in the chat. That's my record that you're here. All right, thank you. How about Bryce? Bryce Block. Okay, I see you. If you would type your name, got you, thank you. How about Sherry Brown? Sherry Brown, yes, thank you very much. And Trevor, you here today, Trevor? Yeah, you are. Okay, good, thank you. How about Nally, N-A-L-L-E-L-Y, Garcia. Ooh, don't see you, okay. How about Brighton, Hout? Yeah, thank you. And Eduardo Herrera, are you here? Yes, you are. Got you. Joshua Aramillo. Joshua. There you are. Okay, thank you. Jacob Jerome. Jacob. All right, good. And Israel Kingswaba. Israel Kingswaba. No? All right. All right. How about Sam? You here today, Sam? There you go, Sam. All right. Nathaniel Norris. Good. Or Nate. Okay. How about Kaidi? Kaidi, thank you. Okay. Abigail. Got you. And Cassandra. All right. Becca. Yeah, there you are. Vincent. I don't see you. All right. How about Amy? Amy, you here? Got you. And Natasha. I think I saw you. Yep, there you are. All right, now, did I miss? Let me double check. The ones I did not get was Callahan, Bauer, Nally, N-A-L-L-E-L-Y, Garcia, Isra, and Vincent. Now, did I miss anybody that's here that's not on my list? Because I may have updated. If you're not on the list, go ahead and type your name in and we'll update it. Yeah. Okay, looks like we've got everybody. We've got 17 people. All right. All right, well, welcome to Chem 130. It's going to be intense. All right. Oh, we got one here this way. So you got one more waiting here. Bear with me. Okay, I saw Cal, C-A-L. I don't know who you are. If you would type your full name in the chat so I can mark you off my list. Cal. Oh, could it be Callahan Bauer? Is that you? Cal? Yes, okay, would you, yeah. Okay, go ahead and type your full name in the chat. So that gives me a record that you are here, official record that you were here. Okay, thank you. All right. Okay, well, we're going to have some fun here. Okay, now, obviously, this is the summer and it's half the time. We're doing 8 weeks. So we are doing 16 weeks of chemistry crunched into 8 weeks. Okay, so it's going to be kind of intense in here. But what I'm going to do today, the plan is this. I'm going to give you a little bit about myself, give you a little background, and then I'm going to go into the syllabus, talk about some aspects about the syllabus, some of the requirements, and then we're going to go over into Canvas and go talk about Canvas and the course and where to find things. Obviously, you found the Zoom link, no problem. There's some other aspects about the Canvas that will help you out with respect to resources, okay? And then we're going to touch on the course website. More information, more resources there for you, right? So if you have any questions, feel free to unmute yourself, ask the question or type it in the chat. Either way, that'll work. And let me start off with who I am, okay? All right, so I'm Dr. Fred, AKA Frederick F. Dworkin. Now, a little bit of background about me is this. I'm a homeboy, okay? I'm an Arizona boy. Grew up in a little small town east of here called Superior, Arizona. You may be familiar with it. If you drive up to go to Miami, you're going to pass right through it. And if you blink your eyes, you're going to miss it. Okay, small town. Well, I left there many years ago. I am a veteran, a Vietnam veteran. I joined the Air Force. And after that, my time there, I was a civil engineer, so I did construction, maintenance. My main job was cement work, and I got into heavy equipment operation, carpentry, plumbing, kind of a little bit of everything in civil engineering. Anyway, I ended up in Kansas City. I received my bachelor's degree from Avila University there in Kansas City in chemistry. Which is ironic because my very first chemistry class I ever took, I totally bombed it. I flunked it out. And I go into Avila, I found that the instructors there, as a school run by Condolet sisters, they just had a way of teaching chemistry that just made it click. So I hope I can take some of that chemistry. Chemistry could be difficult, but what I tend to do, because I've done a lot of work in industry, I tend to try to give you examples, real life examples of what's out there, what you see every day, and apply it to chemistry to help you grasp the chemical aspects. Now, obviously, I'm not going to here to make you chemist, but if you get a real high interest in it, that'd be great. That'd be pretty cool. I've had a few students change their major, but not very many. Anyway, I liked this so much that I continued my education. I got my doctorate in organic chemistry at the University of Missouri in the Kansas City, there in Kansas City. All right, so after that, I was a researcher. I'm retired now, but I'm a research scientist. My main focus was process and product improvement, though I was trained as and educated as an organic chemist. These are the people that go around making new compounds, and sometimes they have medicinal value, sometimes they don't, some kind of value, but it's basically, hey, can we make this compound? But with that background, I went on to process and product improvement. So got involved in the multiple things, not only just chemistry, but I got involved with computer programming and multiple things. So I've been an adjunct now at SCC for a bit, and also at GCC. All right, so I'm in both campuses. Prior to that, I was adjunct for Carrollton College, where I also taught chemistry, but on top of that, I also taught general math and physics for the physical therapy students and the dental hygiene students, okay? So I've been doing this for a little bit. My previous experience in life has been, like I stated, construction, but I also been in customer care, food and retail industry, software programming, and also even caregiving. So got a wide background, a variety of things. I have 9 children, and I have 9 grandchildren. In fact, I got a 2-year-old that you might hear in the background occasionally running around making trouble. So anyway, as I stated, 16 weeks of chemistry. We're going to give it to you in 8 weeks. Okay, so we're basically doubling up on the time. We're not doubling up on the assignments because you're given the same assignments in a 16-week classes. It's just that these due dates are cut in half. So one time you're going to be having like 3 in 1 week. You could be having 3 homeworks due. You could have an exam due, and plus your lab. Okay, the lab is all online. So time management is going to be very, very important here, okay? So, discipline yourself with respect to your goals of getting a higher education. I'm here to at least get you to that goal. That piece of paper does open up things that just right now you may not imagine that you can do, but without that piece of paper, doors do open up. I never thought that I would be sitting here talking to you, teaching chemistry, doing research and development and producing products that were utilized literally around the world. Hometown boy from a little small mining town, that never entered my mind, but I couldn't do it without that piece of paper. So very important, very, very important education that is, and that piece of paper will open up some doors for you. If you need help, get help, especially in the summer class. Not to say it's less than the other semesters, but in the summer, like I stated, we are giving you a lot of information in a short period of time. You need help, get it early. These chapters are set up so the information you learn in one chapter will be utilized further down the road. What I'm going to attempt to do is to combine all the aspects of everything we talked about at the end and kind of put it all together, okay, for you. So everything's kind of, if you have trouble with one of the previous chapters, you're going to have a challenge down the road. So let's get some help. Now, I don't have office hours. However, if you need to meet with me, I have no problem with respect to setting up a time through the Zoom and we can go over the problems, okay? No problem at all doing that. So, but I need to know. You also have tutoring that you can do online or on campus and you have access to. So again, bottom line is this is your responsibility. Obviously, you're paying for this. This is your education. You're the customer. I'm here to help you reach your goals, okay? With respect, at least to this little section of your overall goal of your educational endeavor of what you're attempting to do, okay? So take responsibility for education. I fully understand you're working, you got family. I came up the same route. So a lot of times, you get an instructor, Dr. So-and-so, you think, well, he's teaching, he's got an easy life. But remember, for us to get to that level of teaching here, we went through the things you're going through, taking classes wherever, taking classes throughout the semesters, summer and so forth. From 1976, I believe, to 1993, every chapter, every semester, I took a class. 1976 is when I started my first undergraduate class, and I ended up with my doctorate in 1993. In the meantime, I was working full time, raising a family and so forth. So, and you got to balance your time, and time management, very important. Okay, essential. All right, so much for that. Any questions about that? Any questions at this point? Do feel free to ask anything. What I'm going to do is, now you should by now, hopefully, it was on the to-do list, print out a couple of papers, PDF files. One is the periodic table. It's going to look differently than the one I got here because I got mine marked up with additional information that we're going to talk about. But this periodic table, this table here, I'm going to use throughout the semester and make reference to it 1,000 times. Okay, so very important. Also, when you're taking exams, you are more, of course, you can use this table, but you can't use it from the digital format because that lockdown browser doesn't allow you to go into other sites. So if you haven't done that little exercise, extra credit exercise with respect to the lockdown browser, please get it done because you're going to need it for all your exams. Okay, you cannot take the exam without that lockdown browser. And what happens is you may need this periodic table. So if you have a hard copy of it, you can't access it with digitally because the browser is going to mark it as you left the exam and you don't want to do that. Okay, because that's the whole purpose of the lockdown browser, keep you in that exam. And let's not have any flags saying that you left it for whatever reason. All right, so the periodic table is one thing you're going to need to print out. We're going to utilize that quite a bit. There's a bunch of information. Obviously, the elements are there, but if you look at the bottom left corner, there is a table labeled most common polyatomic ions. We're going to talk about those. Okay, to the right of that, the bigger table is called the Solubility Rules. We're going to learn by looking at the chemicals whether something is going to be soluble in water or not, based on these rules. They look complicated now, but trust me, it's not as complicated as it looks. And second of all, right above the solubility rules, you'll find here another little table called the activity series, which lists a series of metals and with respect to which metal is more reactive than the other. And that's going to allow you to predict certain types of reactions, okay? Certain types of reactions. The solubility rules will help us to predict the solubility of certain combination of molecules or I want to just for this point, at this point, just the combination of chemicals that come together. We'll be more specific down the road and tell us whether it's soluble or not, which then tells us whether the reaction proceeds or not, okay? This periodic table is going to tell us a ton of information. Just by looking at that, you're going to be able to predict, okay, each atom here has a particular diameter, okay? And you'll be able to learn how to predict which is bigger than the other based on their position on the periodic table. So like right now, I can say with respect to diameter, the nitrogen is much smaller, much bigger than the oxygen. And you're going to learn how I came about with that conclusion. You're also going to say that the iodine is much bigger than the fluorine, okay? And that's just part of it. We're going to learn about what type of ions. And what I mean by ions is what happens is these atoms, they're going to lose electrons. We're going to learn it's all about electrons. Crazy thing, electrons. They govern a lot on chemistry, govern the properties, that govern how things react and so forth. And these crazy electrons, you ever wake up with a bad hair day and go, okay, you got that static clean going on? Those are electrons, okay? Anyway, so if you haven't done that, print that out, you're gonna need it. And then the other table is called the shapes table that you're also going to utilize. The shapes table has a lot of information here. There's a lot of information on top, equations that you don't have to memorize because it's there. We're going to learn about these. Okay. Then down here, we have a table called the shapes table. We will be able to look at a formula, a given formula, okay, generate what we call a general formula by something like this, AB4. And from that information, we'll be able to determine, to tell or present what the geometry is. And for an AB4, here is the geometry, which has its own particular name, which has a bond angle. The bond angle is meaning here we got the central atom, and then we got 4 atoms bonded around the central atom. And then this bond angle is that distance between what is bonded to the central atom, okay? That gives us a lot of information. From that information, we can determine whether something is what we call polar or non-polar. Okay, right now it doesn't make sense, but we all know that like dissolves like, right? You know, if you have Italian dressing, you have two layers. You have an oil layer and an aqueous layer, right? Because you got an oil, which is not like the water layer. Light does not, the oil is what we call non-polar, and the water, the aqueous, is polar. Being polar and non-polar, they do not mix very well. Okay. Same is true. Another thing too for you ladies out there who, you know, you have certain makeups that you know, it's called. I heard there's some what's called hurricane-proof makeup. Like you put that stuff on, you're in a hurricane, and that water will not take that stuff off, right? But if you get hit by some, you know, W240, that stuff comes off because that W240 is a lot more non-polar, and it takes it off very readily as compared to water. Okay, we'll have a lot more to say about that down the road. Anyway, I tell you, I use a lot of examples. Excuse me. I've been getting over some kind of allergy or something, so bear with me. All right, so that brings us to the syllabus. I'm not going to go over all the aspects about the syllabus, only some important parts. Okay, so by now you all have one. I sent one an email both through Canvas and through outside Canvas to make sure that you received it. I also have this syllabus in Canvas itself, so you can download it. Either way you have it. Okay, obviously, you know, the Zoom, the room number, we are here, right? We know we're meeting from 1 to 3:30 on Tuesday and Thursday. Okay, the lecture part is classified as live online, whereas the lab is listed as on your time, okay? Now, meaning that the following, labs are gonna be, eventually, we'll go through the schedule here in a second, but labs, will be due at one point. Your first one is due on Friday. It's like an introduction lab. It consists of looking at videos and then answering the questions. That's pretty much what the labs do. Some of them are short, some are a little bit long, so, you know, give yourself plenty of time. But the point is that if you started, you can come back and continue from where you left off, and nothing gets penalized, okay? There's no time limit with respect to the lab, but there is a due date, okay? And we'll talk about that in a second. So don't mix up the two. There is a due date for everything, but some things are going to be required to be completed within the time frame, while other things are not. Okay, and the labs are not there. You can take all week to knock them out, but keep that in mind. There's going to be about 2 of them due a week, so get your time management set up. And looking back at my days in summer classes, I didn't get much sleep with the family and all that. Most of my work was 1, 2, 3 in the morning. So anyway, whatever works for you. We have a course website. Okay. Now the website is being hosted by GCC. GCC, the classes I teach at GCC and SCC, we all use the same stuff, all the books and videos and everything. And so instead of having to create a whole new website here in SC, I just make reference to the website at GCC because it's the same information. We'll go over that. Here's the link for it. The majority of the material on this website you already have in the course, in the Canvas course. I've downloaded it and set it up in modules, okay? But I'll go over, there's some additional resources, mostly like old exams and old homework you can use as a resource to help you out to do more examples of these questions that may be coming up, okay? All right, my information is, I stated, I'm Dr. Fred. Now, email, you need to get a hold of me. I mentioned that already in the emails I sent to you. Do use the Canvas email, okay? Now, if for some reason, and it does happen, it has happened in the past, Canvas is not functioning, then go ahead and use my EDU email through Scottsdale, SCC.edu. All right. I don't check that as often as I do my Canvas. All right. So if you need to get a hold of me, send it through Canvas. And as a last resort, then use my EDU. Okay. My Canvas comes right to my phone, but in my EDU, not only do I get email from you guys, but I get email from the whole campus, not only from GCC, but from SCC. And there's just tons of emails in there, and your email could get very easily lost in there. But Canvas is a separate entity itself. I get nothing but your email through Canvas, nothing else. All right. Plus, that's the official communication mode for instructor student. Okay. I don't have an office location, obviously, and I don't have office hours. As an adjunct, I'm not required. But I will tell you this, you need some help, I will set up time. We can set up time to meet through Zoom and go over any issues you may have. A good time would be like right after class or before class, one way or the other. Okay, we talked, nothing here to say about the course description. We're going to talk chemistry, okay? Prerequisites, obviously you all fulfilled that because you're here. All this here is a listing of the topics that we're going to talk about, okay? And this is as per Maricopa Community College requirements. There's 7 aspects about chemistry that we're going to touch on, and that as per required and required to listen. So there you go. Okay. The text, course material, the textbook is free. All of it's broken up in PDF files in particular chapters. Okay. Every module has that PDF file for you. You don't have to buy anything. Some people print them out. That's fine. Totally up to you. Use it digitally, whatever. But if you need to get a book, it's not necessary, but if you need a book, because some people like to have a physical book, you can print out your PDF files. If you want an alternative book with traditional, you can get a free book. That's option number 2. You go to OpenStax. I think you got to make an account, but you can break down the open resource book, and any general chemistry book would work for you. Okay, but totally up to you. It's not necessary to have a book. You will need a calculator, specifically a calculator that does what's called scientific notation. Okay, that's important, scientific notation. Why is that? Because down the road, we are going to be doing some calculations that utilize humongous numbers, big numbers. And what we're going to learn is how to put these numbers into scientific notation. Scientific notation is a fancy name for just a shorthand method of taking big numbers and putting them in a smaller shorthand format so that your calculator can input. Okay, so you don't need anything fancy. It's not necessary. 10, 15 bucks used one most of them would have a scientific notation function. That's what you need. Scientific notation. We're not going to do anything fancy. A lot of people tell me over the years, I don't like science. Because I don't like the math. Okay, well, I'm here to tell you. If you can add, subtract, multiply, divide, you can do the mathematics that we're going to do. Now, we're going to do a little bit of algebra, just a tad. I mean, just a taste of algebra. It's not going to be intense, nothing complicated. And so I'm assuming you've done that because that's the prerequisites for this class. I know hopefully you can add, subtract, multiply, divide because you got a calculator. And with respect to some general algebra, I'm pretty sure once we go through it, you'll see that it's not that bad, okay? All right, so calculator or scientific notation format. Let's see, Maricopa Systems, we're gonna be using Zoom. Some of you, it's advantageous. I think it depends on your preference as far as Zoom is concerned. You can run Zoom with your browser, or you can download the app The app is free, and then run the course through the app. Whatever works best for you, just run it off the browser or run it off the app. All right, kind of streaming tools. Well, you're going to have YouTube. Everything like this recording, once the recording is done, before you ask, once the class is over, I close it up, and then Zoom then converts the recording into MP3 format, which is great. However, YouTube doesn't accept that. It needs to convert it to its format. So I will upload it to my YouTube channel, and then YouTube does their magic to it, change it into its format, and then once it's done, it's available. What some students have done in the past is subscribe to the channel, and then you get notified when it gets updated, okay? So that gives you an opportunity to listen again to what we talked about here, because you're going to get two types of recordings. You're going to get the recording of what we talk about here, and then you also have, I'll show you where it's at, recordings of the topic, but by another instructor, specifically GCC instructor, Dr. Kim. She created a lot of recordings of the topics. So you have an opportunity to listen to her talk about whatever we're talking about. And then after we're done, listen to me again of talking about what we just talked about, okay? So you have a multiple resources here. Because some people like to, either they read it, the chapter beforehand, which I highly recommend before we do it, because that way you're familiar with the chapter and when I start talking about it. Some people prefer to listen to it, okay? So you got Dr. Kim's videos that talk about the video. So take time to listen to her before you listen to me. And a lot of times, a topic, by hearing it by different people, it clicks in, because sometimes I guarantee you, sometimes I'm listening to somebody talk about something and I just can't, it doesn't click in, but when I hear it from somebody else, it clicks in. So by all means, the more resources you have, whatever it takes to get you to grasp the concept of what we're talking about, use it, okay? All right, we are using the Lockdown browser. Again, it's its own little browser specifically made for the Maricopa system. Okay, now if you used it before, you don't have to download it. It's in your computer or wherever used, iPad, whatever. It's there, so you don't have to do it again. If you haven't, then I put instructions in there on where to go to get it, whether you are Apple or Mac or PC, whether you're using the iPad. Okay, also with the Chrome, if you're using a Chromebook or something. All right, so you're gonna need that because all the exams require the Lockdown browser, okay? Just the exams, not the homework or anything, other assignment. Okay, so you're gonna need that. So get that done as soon as possible. And then once I get notified, I'll give you a few points extra for doing that. Okay. Point about that, do not download a copy of the Lockdown browser from any place else. There's a multiple of them out there, but every Lockdown browser is made for a specific institution. And the one we need is the one made for the Maricopa Community Colleges, okay? We won't be using the webcam, so no worries about that. If some of you have issues with the webcam, feel free to tape your camera with some tape, cover it up. I have no problems with that. It's not necessary to have your cam on, but if you want, then feel free. No problem there. All right, so there's more information about that. We're talking about course policies. Click the link. Some of this stuff is, for your reading. Now, grading practices and standards. All right, so we have the sections. The first section is homework. Every chapter has a homework involved. It's all online, okay? Which reminds me, when in the beginning of the semester, no problem. When you asked me, I had a problem with the quiz. I pretty much know which one probably you're working at, but as we progress through the semester and you have a question, please tell me specifically which one, because Canvas treats the homework and the exams, anything that you do online is a quiz. So if it's a homework, tell me what homework, you have a question about the homework, specifically say homework chapter X, exam number, whichever one you're talking about. Give me, or the lab, specifically tell me which lab you're asking about. Okay, because as we progress, people are going to spread out. Some people jump ahead and start doing the labs ahead of time, which you're more than welcome. All the labs are open now. You're more than welcome to jump ahead. There's nothing about to prevent you from doing that and doing the homework ahead. Okay. All right. So lecture homework is worth about 15% of your total grade. Consists of it's 10 points, short questions, multiple choice. There are 15 homework assignments. The lowest 3 will be dropped automatically by Canvas. Okay. Lowest 3 get dropped. Now, every homework has 2 attempts. Okay. There's no time limit. There's a due date, but they each have 2 attempts. So you're more than welcome to do the first attempt. A lot of students have tried this, is they go, not knowing the chapter, just jump in there and do attempt number 1 and see how well they do. Okay. Gives them an idea of what to expect. Now the questions do rotate, so you won't always get the same question in the second attempt, but be similar. And then students then wait until after they're done with the chapter, and then they do the final attempt. All right, so that's one option you can do. The other thing is this, no homework will be due until after we are done with that chapter. Okay, and so if we are in chapter 1 and homework is due today, that's not going to happen. It just means that I haven't moved the due date. I'll give you a day or so after we complete a chapter to make that homework due. All right, so don't freak out if you see it's due today, but we haven't done it. Well, I haven't moved it over yet. Not to worry, I will move it over time-wise, shift it over. Okay. Let's see what else. Now, there is a penalty if you turn in late homework. It starts at 5% per day until you reach the 50% mark, which is really, if you calculate it, is like a week, 5 days later. So you have a due date, okay? The day after the due date, 5% of that total points are removed, okay? And it continues until it reaches the 50% mark, which means that after 5 days, you're at the 50% mark. And if that assignment was worth originally 10 points, now the max you can get would be 5 points, okay? So even though you answer all the questions right, the fact that it's over 5 days late, the max you can get is 5 points. Well, some points, I wouldn't, just let it go to 0, because some points is better than no point, okay? So, but keep that in mind. There's a note here about homework posted on the course website. That is not your homework on the course website. All your homework is in the Canvas course. The homework on the course website, which I will show you what it is, they're PDF files. Those are old homework that we used to do when we met face-to-face, and but they're additional resource for you, because we still utilize the same type of question. Obviously, it will be it won't be the exact question, but the same type of questions are asked on Canvas. So that's an additional resource to help you to be able to work the type of homework you're going to expect to see on Canvas. All right. Here at SCC, you have your own, as per chemistry department rules here, they have their own requirement called the Nomenclature Exam. It's worth 10%. What that is nomenclature is a fancy name, a word for name that compound. All compounds have names, okay? Sodium chloride, okay? Potassium chloride, ammonium phosphate, things like that. Those are the naming of the compound. Well, the department requires that that a nomenclature separate exam be given, and that you must pass at least 80%. It consists of 20 questions. You either be given the formula or you're given the name, and you have to do one or the other. If you're given the formula, write down the name. If you're given the name, give the formula, okay? So of the 20 questions, if you got to pass 16 of them, that gives you 80%. Anything less than 80% gets set back to 0%. Now, the thing about the nomenclature exam, you have an unlimited number of attempts. So you can try as many times as you want to hit that 80%. Now, we are still teaching Canvas. The thing to tell you something about Canvas. Canvas is not a very smart piece of software. We have to tell it everything. It's not AI by all means. And so I go in there after you take your exam because some answers you give are correct, but for whatever reason, Canvas says, no, it's wrong, which brings me to the point. Anything you take in Canvas, and if you get it wrong and you know 100% that's correct, but for whatever reason Canvas marked it wrong, let me know. I definitely will go in there and check it, see if you're correct. If you are correct, I will give you your points, no questions asked, okay? Because like I said, Canvas is even for example, let's say you type in an answer and you add a space. A simple thing is adding a space after your answer. Well, Canvas reads that space and counts it wrong, okay? Well, obviously, it's not wrong, it's right. You're getting the right answer, you just add in an extra space. And so, or you might give a space in between the words or letters, and I would definitely give you your credit for that. And that's for anything Canvas does, grades, and you know it is correct. All right, so the nomenclature exam, and I do have a study aid for you to help you with this exam. And we will be, as we progress in this every chapter, I will go give you examples of names as we progress. There is a whole chapter on nomenclature, but prior to that, as we learn about the chemicals, I'll be talking about here's the name of this compound, so on and so forth. All right, now, would it hurt my grade if I don't make it the 80% mark? And the answer is depends. It depends of where you're at, okay? Because that 10% can make or break you depending if you're on the border. If you're on the cusp there, that 10% can drop you from an A to a B. At the same token, it can drop you from a C to a D or from a D to an F. At the other end of the spectrum, it can kick you up from a B to an A, okay? So depending on where you're at, you know, it can help you out or it won't affect you. So, you know, again, this is your education. You're trying to get as many points as you can get. You know, I strongly recommend you get that 80% because it'll do nothing more than help you along the way. All right. All right, lectures, you're going to have 5 lecture exams, all online. That is worth 35%. And then you're going to have a final comprehensive exam covering all the chapters. Chapters 1 through 15 will not cover the last chapter, 16, which deals with that. Okay, so the first chapter. And it consists of the final exam consists of comprehensive, and it'll be 60 questions, all multiple choice. Okay. All right. Lecture exams, 5 of them. Let's see what else. Your experiments, there are 11 lab experiments, which, you know, you sit there and you look at videos and answer questions based on what you observe from the videos. And then there will be 2 lab exams kind of broken up somewhere in the midterm. You'll have an exam for labs 1 through 5. And then at the end of the semester, an exam for the remaining labs, okay? All right, so 25% of your grade, which includes the lab exams and experiments or overall exam. As the homework, there is a due date for the experiments, okay? And past that due date, there's again, as a homework, 5% penalty per day until the 50% mark. All right. All right, our exam, this is a slightly different scale than most departments, but your 88 to 100 is listed at A, and then 78 to less than 88% is B, so on and so forth, okay? So it's about 2 points less than the normal 80, 90, 90, 80, 70 scale. All right, so this is the breakdown, 15 homework assignments. The lowest 3 will be dropped automatically by Canvas. That is worth 15%. There's 5 lecture online exams. That's 35% of your grade. The 1 nomenclature exam, which is worth 10%. The comprehensive exam, which is 15% overall grade. And then the experiments and the 2 exams are worth a total of 25% for a total of 100%. Okay. Response time, I do my best to get back to you ASAP. Occasionally I can't for multiple reasons, but I would definitely get you an answer to your email within 24 hours, okay? And if I need something to grade, most everything is automated, so you get your homework, you get your grade right away. Certain things I need to go in there and look and grade your exam. Could be the exam, could be the lab, okay? I need to go in there and look at your answers. And that would take me a couple of days to get that knocked out. So it should be pretty quick for you, all right? 2 to 3 days, everything should be graded. Now, being online, we had to redefine what we classified as attendance, okay? Attendance is defined as attending a lecture, that's part of it, attending the Zoom lecture exam, and submitting your assignments on a weekly basis. Okay? Simply logging onto campus doesn't constitute attendance. You must submit something, do something. So come to class. I know sometimes you can't make it. I mean, treat it as you're online, on face-to-face. Sometimes you can make it to class, sometimes you can't. But don't let that information go by the wayside, okay? Because I have that stuff recorded. Make time to listen to what we talked about, okay? All right, so having given that information, I have, if you're missing, like I stated, there are due dates. If you have 5 or more missing assignments, I have the option to withdraw you. I don't want to do that. And what I do is I check it periodically. And if you're getting close to that level, I send you an email saying, hey, we're getting close there, okay? And again, if you don't come in and if you don't log in Canvas at all, for 2 weeks, then again, I have the option to withdraw you from class. So if there's something going on, please let me know right away. Tell me what's going on, and we'll find a way to, get things back online. All right. There's some additional information. We've got at least 3 to 4 hours of content. We're going to be here from 1 to 3:30. So I'm saying you're here for the whole time. You're going to be listening to that. You're going to spend at least 2 or 3 hours on the labs. Because some of them are long, some of them are short, so make some time, set some time away so you can accomplish that. And then you got the homework, okay? Which are fairly short, shouldn't take too long. There is online tutoring. There's a link there for you to get going with some online tutoring, okay? And as I mentioned before, if that doesn't work out for you, I'm here. We'll make arrangements to do a Zoom thing around your schedule. Okay. Question about the withdrawal policy. As far as you drawing on your own, there is a time limit. I believe that's coming up where you get a refund. I believe that's the 6th of June. I'm going to verify that. But I also have the option to withdraw you if you request that. But if I highlight it here, I cannot withdraw you, and I hope we don't have to do this, but if for whatever reason we need to withdraw you, I cannot withdraw you if you take the final exam. So if you're having challenges and you think maybe it's best a withdrawal, let me know ahead of time. And if you request that, send that request through Canvas email, so I have official record that that's what you're requesting. Okay, but let's hope we don't have to do that. Some more information for you to learn. Now, here is the schedule. If you haven't had time to look at it, here it is. Okay. Today in yellow, we're starting Zoom, obviously, and once we're done, when I'm done with the information, I'm going to start in chapter 1 and continue on Thursday. Now, Friday will be, I moved the labs over. I figured I'd give you a little more time. So the first lab will be due Friday. I labeled there lab 1. So you can see that every Wednesday and Friday, there is a lab due, okay? Tentatively, homework number 1 is on Monday. Okay, we should be done with that chapter way before then. And then on Tuesday, we'll get into chapter 2, I should say Thursday. So lab homework number 2, 1, 2, and 3 are due next week. Okay, keep it in mind. We should be done with those 3 chapters by the end of next week for that homework to be due. If for whatever reason we're not, I will move that time over, okay, for the homework. Your first exam is on the 3rd week, which will cover chapters 1 through 3, okay? So you can see that that is the general trend, that literally after on the 3rd week, you're gonna have, I gave enough cushion there for us to get through those chapters. So from starting the 3rd week to the end, you're gonna have basically an exam a week, okay? And then you have in between there, you have the lab exams. And then our final exam I've highlighted in yellow is on Thursday. Now, also, that is the last day that you can turn in any of the assignments, like the homework and the labs. Okay. Now, even though they have a due date, they are still open until the end of the semester for the homework and the labs. They'll be penalized, but you can still turn them in, okay? And get some points rather than 0 points. Okay, any questions about this? Now I'm gonna give you heads up here a little bit. I'll know more once you get closer to that time period, but roughly this Tuesday, that Thursday, and yeah, this one and this one, probably those 4. I'm probably lecturing from Kansas, so I'm on the road. I got to go meet my kids and see my kids, so I'll be lecturing from Kansas. I put an outside pool. I kind of thought maybe I'll pick my laptop and sit out there in the pool, but I figured no, it wouldn't be fair to you guys. So, all right, just kidding. So when I get more, I nail that time period, I'll let you know, because we may have to maybe fluctuate the time a little bit depending on when I'm on the road. But I shouldn't expect any time changes. I'm just saying, just heads up. All right, any questions at this point? So you know ahead of time, here's the thing here. You know ahead of time what's expected, what's due, okay? Because there shouldn't be anything I didn't know it was due today, because I printed out, I made a schedule for you here. Not only that, I will show you here in a little bit when we get into Canvas, that Canvas can alert you that, you know, when things are due, okay? So, any questions? Which, by the way, sorry, I forgot one last point. There are 2 questions. No questions? Okay, so the lecture will be during the lecture time. And the lab, yes, exactly. Here's the thing. Oh, good question, Amy. Those days that have exams, all exams 1 through 5, lab exams are basically on your time. The exams, I open up at 7 a.m. You have access to them, and they close at 11 p.m. that day. Okay? So you have from 7 to 11 p.m. to set some time away to knock out that exam. So it won't be during the lecture time. Now, what I do is on those days we have an exam, I'm here, we do a lecture, and if there are any questions concerning the exam or chapters for that exam for that day, I continue with the lecture for the next chapters. Okay? So, and the same is true for the final. It will open at 7 and shut down at 11 p.m. The final exams 1 through 5 and the lab exams are on your time with respect to from 7 to 11 p.m. Okay, and I will be here for the exam days to do the lecture, or if you have questions concerning those chapters, we will go over the questions. Okay, does everyone got that? Is that clear, Amy? Did you get that? Okay, all right. Thank you. Now that brings me to a point. Now there's an advantage to doing lecture on exam days because we're online. You basically can do them on your time, and that's why I open it up from 7 to 11. So you got all that time. So you know ahead of time those are your exam days. Now, if for some reason maybe your work schedule, you got a new you're told you got to work the next day or something, and you need to change that time, I can go 1 or 2 days, one direction or the other, if you have a legitimate reason. If you can't take it on Tuesday and you got to come maybe Monday, I have no problem with doing that. Just let me know beforehand, okay? Please don't let me know like the day of. All right? All right. Now, by doing lectures during the exam day, what that does is toward the end of the semester, like right here, and possibly right here, we basically will be finished with the chapters, and that leaves maybe one. No worries. That leaves maybe 1, maybe 2 days that we can leave as a question and answer session. Okay, it depends on how we progress with the semester here. During the regular semester, we generally have maybe 2, maybe 3 days at the end that we are opened up for question and answers. I come here, I'm still here, but we're not lecturing, and students come in with questions and go over whatever chapters you want to talk about. Okay, so we'll see how that goes for the semester, but for sure we have at least 1, possibly 2 question and answer sessions to get you ready for the lecture. I will definitely be here, even though the finals that day, I will be here for at least an hour or 2 if necessary for any questions you may have during the regular Zoom time. Okay, a lot of people need that little last minute clarification, and then they go on and do the exam. All right, so like I stated, all exams will open at 7 a.m. and shut down at 11 p.m. So you have a long time there to set some time aside so you can complete those. The exams are 75 minutes that you have time-wise. These exams, you can see you got 75 minutes of time. And the final exam is almost 2 hours, like 1 hour and 50 minutes time-wise. Okay, so knowing that, set yourself, and they average based on the previous exams that are given. Average time for exam is roughly 1 hour. That's about the average time. 1.5 hours for the final. And so give yourself plenty of time during exam days to knock that out. Okay? Any questions about that? All right. So And like I said, the homework, these are tentative due dates, depending on how we progress with respect to the chapter. All right. Give me 1 second. Let me write this down here. All right. Syllabus, we got tables. Let's go visit. All right, on Canvas, I'm highlighted the calendar. Okay, I like the calendar function here because it gives me a breakdown of everything I need and what's due and so forth. Okay, obviously make sure you highlight on the right side your classes so you can see what's due. Now, another little thing here that you may be aware, may or may not be aware of, is that if you click on the far right, called the calendar feed right there, what that does, it creates a link of your calendar, okay? And it creates a file, a ISC.ICS file, that then you can email to yourself and open it up. So your Outlook, your Google Calendar, or whatever calendar that supports a .ICS file, it will open it up, and this information then gets transferred to whatever calendar you're using, your cell phone, whatever. That way you know at all times what things are due, okay? In your notifications, I believe you can also, in the Canvas notifications, you can also fix it to notify you that what is due, what's coming up. Now, what I want to do is I want to put this in your student view because my view is a little bit different, okay? All right, so a couple points here. In the home screen, by default, this is what you see. This course is broken up in modules, okay? Well, the first thing is I created a multiple of announcements that you should go in there and read about them. It will help you with information concerning the topics that we're going to cover and some other information that you would just find interesting, okay? So obviously you know about my link with the Zoom, that's in the far left. And then you got the YouTube, okay? If I click Dr. Fred's YouTube recordings and I open it up into another tab, this is what you'll see. Right now, obviously there's nothing there, but this is where your recordings that we make here in lecture time here will be uploaded. All right, we have announcements, which of things I've created to help you. Not only have I created, but SCC also uses this function here to send announcements to all the students. So most of this is mine, but SCC will also send you their stuff. I like the syllabus link, which I really would wish I could make it default, but I got to stay with the format the SCC wants and make the home something different. But in this syllabus here, it shows you, obviously you got my syllabus that you can download, but you got a course summary, and it breaks it down as due dates as far as assignments, so you can look at what's coming up at a glance, okay? All right, here's a breakdown of all the weighted assignments. Now the modules, as I stated, all the modules, every chapter section is broken up into modules. Now SCC puts this information in, and I've added my material in that welcome module. SCC has the first step information that you want to read. Now I've added this one called additional chemistry resources. These are some simulations that I'm going to talk about them, but you can go in there and click them and see what they do. They will help you to understand the concept and the theory of how an atom is put together, okay? And then we're going to talk about balancing chemical equations. Okay. Now you might think, well, what's going on here? Hold on. Well, you saw the table of elements. You know, there's 118 elements. Obviously, we're not going to talk about all the elements, 118, but we're going to talk for a large number of them. These are the elements. Now, from the elements, we make compounds. Okay. And from the compounds, we're going to react other compounds to have chemical reactions. Right? It's very analogous to our language. We have the alphabet, right? We got the alphabet, which represents the elements. From the alphabet, we build words, right? Well, from the elements, we build compounds. And from the words, we build those words into sentences and into paragraphs. Well, once we take those elements and build them into compounds, we react those compounds with other compounds to make chemical reactions. And here's the kicker. Of all the chemical reactions that occur out here in nature, there are only 6 types. 6 types, different types of chemical reactions. You would think it would be like 10 billion different kinds of reactions, but no, it's only classified as 6 types. Much more on that later on. Anyway, there's an interactive periodic table. If you click on that, you actually have to go to another link outside. And you can click on any element, and it gives you some background information about the element, that particular element. And there's a crazy looking scientist up there talking to you. It's kind of an interesting character. Anyway, that's in the additional chemistry resources. There's one module called the nomenclature test. That's a test that I told you about that you got to score 80%. And you need the lockdown browser to function. But in there are other PDF files that talk about names and how these, we're going to go over all those things, but there's additional information there for you, which then brings us to the chapters. Now, within each module, which is each chapter, you will have an overview of what we're going to talk about, okay? Also listed there will be the text file for you for that particular chapter. And then you're going to have these videos. Now, these videos are the videos from Dr. Kim at GCC. These are the ones she created beforehand with respect to chapter 1, which is matter. Okay. So now you have an opportunity to kind of pre-listen this chapter. And then once we talk about it, I take my files and I upload them to the YouTube, so you have another chance to listen to what we talked about. In fact, don't just leave it to Dr. Kim's videos and my videos, because if you go to YouTube and you do a search for, let's say, chemistry or matter, you're going to find 10 billion videos out there. Maybe another person listening to someone else may make it clearer or make it, more sense to you. Feel free to search. You have the resources out there. Just just use them. All right. Now there is a worksheet which pertains to chapter 1, which deals with problems for chapter 1, and it's there. Do work them. Again, the keys. It also has the answers at the end, but don't look at the answers till you're working through them. Okay. These are the type of questions that you will find in exams and in homework. All right. Then once you're done with all that, then you have the quiz or the homework, I should say, for that particular chapter. I've also included in there my PDF files for the slides that I go over. So you have, again, I can't give you the PowerPoint slides, but I can give you all the slides in PDF format for you to visualize. Some of the slides we utilize, some we don't, but nevertheless, you have a way to follow along and write notes on it. You print them out and you bring them with you during our talk here. So there's a ton of resources here for you, okay? And then there's the first activity that really needs to be done as soon as possible, just to verify that your lockdown browser is functioning and everything is good to go. Because once it's good to go, that tells me you went through it. When the first exam pops up, you won't have any problem. Okay, you're ready to roll. Now you can see all the other chapters, the same thing. very similar. You got an overview, the text file, videos about that chapter, the worksheets for that chapter, the homework for that chapter, and then my PowerPoint slides for that particular chapter. And that's broken down for you as all the way through the chapter 16. And then we have the actual what's the word I'm looking for? The final exam. Okay. It is missing. I don't know where it went, but I'll put it back in. But there is a previous final exam example that for your resource. Okay. Then we got the evaluation that won't be open until July 20th. And then I do give extra credit, so this is one of them. All right. Then the online labs module, which is basically all of the labs, okay, and including the exams for the labs. And then I've already gave you the PowerPoint slides, but they're listed there again in their own particular module. Okay. All right, the assignment click button here in the far left, basically breaks it down to all the assignments, all the upcoming assignments all listed for you. Okay, so again, you have no reason not to know what's due and when it's due. It's given to you here. StudyMate, if you click on that, okay, this thing pops up. You can just click here, don't show again, because this tells you about the StudyMate. And just continue, click the red button here, the red link, and it brings you here. Now you can create your own project, but you already got one here for you. It's called the Nomenclature Practice. Now what this does is how it's basically, if you click it, let's click it. Okay. I would just stick with either matching or flashcards. It's basically making flashcards. I believe I uploaded like 119 compounds and compound names, something like that. And for example, you have the name here, manganese, Roman numeral 2, nitrate. The question is that you ask yourself, since you're given the name, they want you to give the formula. So flip it over, there's the formula, okay? And you can proceed with, here's another one, dichlorine monoxide, okay? Right now, this looks like it's giving you the names. They want you to give you the formula. Keep in mind that this doesn't support support subscript. So I want you to keep in mind that when you see this, what you really should be seeing is subscript 2, okay? But unfortunately, it doesn't support the subscript or superscript. All right, so that is the StudyMate tool. Then, of course, your grades. I'm not sure about Folio, but you get the SCC library. Okay, so that is the view, the student view. All right, let me do this. Right, I have a link for the course website. And like I stated, it is hosted by GCC. Now, there's a lot of information here, okay? And the important parts from my end are this. You got old homework right here with the key. The PDF files you can download to give you an idea what type of questions are being asked. We even have old exams, okay? Right? Old exams, right? Disregard the tutoring because this is GCC tutoring. But if you click on textbook and videos here, let me clear this up. The links chapter 1 basically sends you to the PDF format for chapter 1, which you already have. The worksheets you already have in your module. These are the videos, okay, that you will find in the modules the pre-videos from Dr. Kim. And if you need captions, okay, feel free. On the last column, it's the same videos, but with captions, okay? But like I stated, all this information is already transferred over to the modules. But if you want to see them here, feel free, okay? Feel free. So that is the old, that is the course website, which is getting updated. All right. Do we have any questions? All right, no questions? We got 216. Well, I tell you, let's take a 15-minute break. And I got let's go come back at 2:30. Let me pause the recording. Okay, I'm back. Natasha has a question. It's a good question. It has to do about the labs question. Now, keep in mind, like I said, the Canvas treats these assignments in the lab as a quiz, but there's no time limit. So let me give you an example. Let me open up the first one. Let me share the screen. And if you click on it, what's going to happen, you'll have the instructions, okay? And then you'll be your first either question or section. No question yet, but it says here, read through the chemistry department safety rules and your syllabus, which is posted on the homepage, blah, blah, blah. And then there it is, the PDF of the safety rules. Read that, and then there's a question there. And watch each video. As you progress, there'll be questions that may or may not have videos, or the questions come from, for example, that PDF, okay? So let's do another one, for example. That's the first one. So go ahead and click it, answer the questions, you know, and if you were to start it and then come back and do it again tomorrow, you will end up make note of where you ended up, just to make sure Canvas doesn't lose your spot. And then you continue with the exam or the quiz or the assignment. For example, let's go back and let's do number 2, which is more getting into the chemistry aspect. And we're going to preview it here. I don't want to start it, but you'll notice here that the first section says there's a video. Okay, so look at the video, listen to it, see what it has to say, and then question number 1 has a question concerning what the video just talked about. Okay, and then question number 2, same thing, so on and so forth. All right, then there's another video, look at question number 4, and from that video, then answer the questions, 3 questions coming up. Okay, so you see how that works? Okay, Natasha, did that answer your question? Yeah, okay. Yeah, good questions. Any other questions, comments, concerns? Now, you can't do that with respect to the exams. Once you start an exam, the clock starts ticking, okay? So that's the only, and the same thing with the homework, there's no time limit, just like the labs, no time limit. So if you start it, you can come back to it. Okay. All right. All right, well, let us jump into chapter 1 then. If there are not any questions, we will jump right in here. Put your trays in the upright position, because here we go. All right, chapter 1, dealing with matter, okay? Now, well, let's talk about chemistry first for a second. What exactly is chemistry is the question people ask. Well, I'm glad you asked. Chemistry is the study of the composition, the structure, the properties. Things like, what we mean by properties, is it a liquid, is it a solid, is it a gas? Okay. The physical and chemical changes of matter. Physical, well, does it go from solid to liquid, from liquid to gas, or under certain conditions, does it blow up? That's a chemical change, a chemical reaction. Okay. We do know this, that all matter is made up of atoms. Okay. And what we're going to talk about is we're going to talk about the atoms, basically talking about matter, okay, and find out that matter is made up of atoms. But what makes up the atoms? Well, they consist of what are called subatomic particles. Specifically, we're only going to talk about three of the main ones: protons, neutrons, and electrons. Okay? Protons, neutrons, and electrons. Now, these particles, which is beyond the scope of this chemistry, are made up of even smaller particles. But we're not going to talk about those. It's beyond the scope of this class. But if you're interested, next couple of levels of chemistry would get you into that aspect of it. So we're going to stick to protons, neutrons, and electrons, which combined make up what is called the atomic mass, what the weight is of that material. Now, I use the word mass and weight. I shouldn't have done that, because mass and weight are slightly different entities. But because one of them is governed by the gravitational forces, and the other one is just governed by the amount of matter in it. But we tend to interchange the term mass and weight. Why? Because we're stuck here on the Earth. Okay, and we'll have more to say about that in a bit. Okay, we're also going to talk about chemical bonding and reactions. We're going to learn that chemical compounds come together by, only two types of bonds, really. Okay, a type of bond is very analogous to two magnets come together and attracted to each other. Okay, they just come together because one is a positive and one's a negative, or one's a north, one's a south. They come together and attract each other. And then there's another type of bond where we are actually sharing what are called electrons. They're actually sharing them, okay, slightly, and they cause totally different properties. Now, we're going to talk about reactions, and I mentioned briefly, of all the chemical reactions that occur out in nature, there's only 6 types of reactions out there. If you drove your vehicle today, or this past weekend you were cooking out and burning some propane gas, that's one reaction called combustion reaction. If you have too much to eat, maybe too much hot sauce, and you're chucking down some Maalox or some Tums, there's another type of reaction. It's an acid-base reaction, because your stomach is full of acidity. You're taking Tums, which is a base, and you're neutralizing that acidity. Another type of reaction, but much more on that down the road here. But we're going to talk about the periodic table and the trends in the periodic table. We'll be able to look at an element and its position on the periodic table, and give us a lot of information relative to the other atoms, just simply based on this position. Okay, we're going to talk about the different types of chemistries. Acids in your stomach. I use this quite a bit as an example. You're going to get tired of it, but there's an acid in your stomach called hydrochloric acid. Okay, and we're going to talk about bases. Tums is a base. Sodium bicarb is a base. When an acid and a base come together, they neutralize each other. And depending on the type of reaction, you're neutralizing the acid and the base. Okay. Electrolytes. We're familiar. We should be familiar with electrolytes. I'm sure some of you are drinking, you buy a container of electrolytes because, we're told we got to drink these electrolytes because our body needs them, which is correct. Our body needs these electrolytes. Okay. Oh, bear with me for a second. I got a little bit of a problem here. Okay. And electrolytes are nothing more than these atoms that either one or two things have happened. One, they lost electrons, or two, they gain electrons. It's a matter about losing and gaining electrons. okay? And we're going to learn about the charge of these electrons. In fact, that's one of the reasons I got into this whole thing in chemistry, because I was just amazed as to the power of electrons. The loss of a simple electron, which is minute in size relative to the rest of it, totally changes the properties of the chemical. You know, you have a chemical who's deadly in that it reacts with water, very violently, and it loses an electron. And then after everything's said and done, that same atom that lost an electron is something that we put on French fries and have no problem ingesting. All because it lost one tiny electron. Anyway, electrolytes are important because they conduct electricity. Electrolytes in your body are important because they're nothing more than elements that have lost or gained electrons. And we need electrons in our body to get electrical signals to get from point A to point B. Okay? We're going to talk about mole, right? No, not mole. That's what I thought the first time I saw that. It's called a mole, okay? And it's a concept that sometimes it confuses people. But that concept is pretty straightforward, because if I said to you a dozen, you already know in your head, oh, we're talking about 12. Well, the mole is nothing more than a number. It just happens to be a very big number, okay? And more on that down the road. Here's a fancy word right there called stoichiometry. We're big on using fancy words to explain straightforward things. So let me break it down for you. Stoichiometry. You already are familiar with stoichiometry, right? You got a car, okay? Or you know somebody has a car. You know that car requires 4 wheels. So the stoichiometry of the wheels to the car is a 4-to-1. I need 4 tires for that one car. If you got a tricycle, guess what? That stoichiometry is 3-to-1, 3 tires to 1 frame. If you have a bicycle, 2-to-1, right? 2 tires to 1 frame. And if you have a unicycle, 1 tire to 1 frame. And that's all stoichiometry is, because we're going to learn that when we got reactants, reactant A reacting with reactant B, that most of the time, a lot of times, it's a 1-to-1 ratio. But sometimes it could be a 2-to-1 ratio, or a 3-to-1, or a 2-to-3 ratio. That stoichiometry is extremely important, especially when we get down to doing calculations down the road, okay? Intermolecular forces. This is where these crazy electrons come into play, because think of this, we have an atom, and surrounding the atom is a cloud of electrons. We're going to know more detail here later down the road, but our motto is this. We talked earlier about protons, electrons, neutrons. P is the proton, and N is the neutron. They're generally in the center of the atom, the nucleus of the atom. And orbiting around them are, I'm going to designate as little e, is the electrons. So around the nucleus are these electrons. Yeah, here I only got 1, but some of these elements have just a lot more of them, okay? And so what's in effect, the nucleus where the proton and neutrons exist are way deep inside the atom. And what's on the outside is the electrons. Those are the guys that are interacting with nature around us, okay? When you grab something, when you grab this pen, anything, there's electrons on the outside of your skin, and there's electrons on the outside of this pen. And so we got electron interacting with electrons. Okay, we never touched the nucleus, just the electrons. And these electrons have a big effect on the properties of chemicals. And this is what we mean about intermolecular forces. These are the forces which I said earlier about something that is polar or nonpolar, and that's this attributed to the electrons around it, okay? And they're gonna have a big effect on how things behave. We know that honey, for example, a cup of honey flows very slowly when we try to take that cup and tilt it over, because it's very thick, right? And it's very thick because these electrons around the molecules of the honey are interacting with each other very strongly compared to, say, a cup of water, who's a lot less viscous and flows more readily. So we have a whole chapter about intermolecular forces, and it has a great big effect. These electrons, for being so tiny, have a big effect on properties. Solutions, okay? We're going to make up solutions, no big deal. You know, if I'm making a cup of coffee is nothing more than a solution. All right. All right, so we're going to talk about that. And we'll probably talk a little bit, we will talk some about gases at the end of chapter 16. Okay. All right. So branches of chemistry. There's, like any field, you know, as you go to, say you go to your medical doctor, you know, you got the general practitioner, you got your brain surgeon, your orthopedic surgeon, your psychiatrist, you know, everybody is an MD, right? Everybody went to medical school. But later on down the road, they became more specialized. Well, chemistry is no different. Okay, you have areas like inorganic chemistry. My field, as I stated, my training was in organic chemistry, where we synthesize compounds. That's a specific type of chemistry. And then you have biochemistry. That is chemistry of life, you know, chemistry that deals with biological systems. We have physical chemistry, which they deal with properties of chemicals. You know, it's just one part of it. You know, and we have Dr. Kim, for example, the one I just mentioned that made those videos. Her doctorate is in chemical education. All right, so she went on to learn how to teach chemistry. And then, of course, we have the environmental chemist and analytical chemist. That's just a short. Some of these kind of interlock with each other, you know, the environmental and analytical kind of work together, you know, sometimes. But, and we have forensic chemistry, another area. So quite a bit of different fields. Now, why do we study chemistry? Now, I'm not going to say this is the most important class in the world that you're going to take. No, I'm not going to say that. What I'm going to say is this, that this class, with respect to chemistry, involves with every aspect of your life. And you may not be aware of it. Everything out there, including you, as you sit here, listen to me, deals with chemical compounds and chemical reactions, okay? And everything we make out here, as far as everything around us, is a chemical process to make. Batteries is a chemical reaction occurring to generate electricity, okay? Cleaning water up, it's a chemical process we do to get water purified, you know, or to make energy, whether it be windmill energy or radioactive energy, you know, nuclear bombs. All these are chemical, TNT, all of them deal with chemical processes, either to make or to get them formed and so forth. So they're all around us, okay? Unfortunately, plastics, so they've helped quite a bit over the years. They've gotten out of hand. And plastics, you know, because these chemicals have such a long life, they can cause a lot of environmental problems. Anyway, chemistry does impact us in every aspect. Now, as scientists, we utilize what's called the scientific method. It's basically steps, okay? And quite frankly, you probably use this without really understanding what it was, okay? It's not complicated, okay? Okay, let's make, you know, it starts off by making an observation. You made an observation of something that occurred, okay? And so maybe for this example, you took a soda can and you stuck it in the freezer and you came back a few hours later and it exploded. It's all frozen, but cans all deformed and opened up. So you made an observation that my soda exploded in the freezer, okay? So you think about this, you wonder, well, I wonder what happened. Okay, so you maybe make a hypothesis. It's your best guess based on the information you have or you know as to why that soda exploded. And you might come across and say, well, you know what? Maybe the water which formed ice expanded when it froze. That sounds logical. Okay. All right. So that's your second step. You formulate hypothesis. Well, one of the big things is we go look after we form a hypothesis, we go look at the literature and we look around and see if maybe something like this has been done before. We look at the sources out there. Has anybody studied this before? Has anybody made this observation? Okay. Well, we gather that information of any, and then we design some experiments. We come up and say, all right, well, let's see if we can repeat what we observed, but this time we're going to do some changes, some variation. Maybe we're going to put a different kind of soda in the refrigerator. Maybe we're going to put different volumes in the container, okay, and see what happens. You know, come up with some other experiments that we can attempt. And then after we're done with the experiments, we can look at the experiments, analyze the results, maybe repeat some experiments, okay? And then maybe look at a hypothesis and see if it's still consistent with what we made the first time. Okay? And if not, we, you know, at this point in time, we could probably, depending on what we're observing, what we've done experimental-wise, we could, you know, change the hypothesis and repeat experiments as needed. Well, once we're done, which in reality, that's one of the difficult things in science is when do you know when you're done? You know, sometimes you just have to just call it, say, okay, we're done. Let's draw a conclusion. Okay. Draw a conclusion of what we observed based on our experimentation, based on what we looked up in the research as far as the literature, what's been done before. And then we may even write it up and send it in for publication. Hopefully other scientists would then read the paper, and then do the experiment itself. And hopefully they get the same results as you did, okay? And so that's basically stepwise the steps of the scientific notation. Make an observation, formulate your best guess, hypothesis. Research that guess, see if anything's been done before, okay? Create some experiments, okay? After we're done with that, look at your results, maybe readjust the hypothesis, the best guess a little better, okay? Repeat the experiments to make sure they are repeatable. After all said and done, do a conclusion, and then at the end, hopefully publish your results in some scientific journal, and then other scientists then would read it. They in turn will repeat the experiment and hopefully get the same results you did. If they did, they generally will send in a note or something. Well, we didn't get this. You know, you gotta rehash your hypothesis. Okay. One of the key aspects is observations. The labs you could be doing. You're looking in a video. You know, be observant of what's being done, because there'll be some questions coming up with what you observed. All right, so things like, you know, color, clarity, for example, observing the state of the matter, whether it's a solid, a liquid, or gas. Okay, so observations are important. Okay, as I stated earlier, matter is anything that has mass and is made up of atoms. Okay. So anything that has mass and is made up of atoms. Now, there's the 3 states of matter that we're going to talk about. There's actually 4, but we're not going to talk about that one. We're going to talk about the solid, the liquid, and the gas phase. And the way we kind of depict them in diagrams is as follows. If you look at the far left, this diagram depicts a solid. You can see here that the spheres represent these individual atoms. Notice how ordered they are. They're very ordered state. Everything is all lined up, okay? And they're all close together, as close as they can get. They can't get any closer. That's as close as they can get, because remember, on the outside of the spheres are the electrons. And we're going to learn that these electrons have a negative charge. And when you got two negatives up against each other, they repel. So there is a limit that we can't get any closer, okay? We're as close as we can get. But the diagram depicts it as very ordered, very structured. Now, with respect to a liquid, the spheres are still close together, but they're not as uniform, as ordered, as structured as a solid was, okay? They're together and they're flowing, they're moving about each other, past each other, okay? Whereas a solid, they're frozen in time, if you will. They're not going to move very readily. Liquids, the spheres, which represent the atoms or whatever the material is, can flow from one point to the other. And then if we look at the liquids, yes, we're still dealing with the sphere, but they're separated quite a bit from each other, okay? Separated quite a bit from each other. And that represents a gas phase. And, you know, you can visualize how water can undergo these changes where, you know, you got frozen water moving all the way across to gas. And all we do is put energy. We put energy on, denoted as E or heat, okay? You know, you take a ice cube and you heat it up, it melts into liquid. And if we continue to heat that liquid up, it goes into the gas phase, okay? And what we're doing in doing that is in between these spheres represent this intermolecular force that I talked about in a couple of slides back. If these intermolecular forces are strong, it takes a lot of energy to break that interaction apart. It will break it apart, but it takes a lot of energy if those forces are strong. If they're weak, it won't take as much energy, okay? And that affects what's called the physical property. Something that melts at a lower temperature has those weak forces compared to something that melts at a higher temperature. Those forces that hold everybody together are stronger. All right, so these diagrams depict solid, liquid, and gas phase. The fourth phase, if you want to know, is the plasma. The northern lights are made up of plasma, but we're not going to work with that. Okay, some of the properties of solids. Okay, first of all, again, a lot of the stuff pretty self-explanatory. So you're like probably looking at this and saying, yeah, I know this. Okay, that's okay. Right. Solids have a fixed shape and a fixed volume. Right. So let's assume this box here is solid, solid material. It has a fixed shape, and I can measure the length, width, and height to get a volume on this thing. Okay, it has a fixed volume. Okay. Now they're together. Call that diagram where the spheres are very close together. They're stuck. They're frozen in time there, if you will, and they just sit there and they vibrate relative to each other because they can't move. Okay, matter will always, even the solid form, will always be vibrating. It's not until we'll learn down the road that if we were absolute zero that we can stop that, but it will move. Generally, solids are crystalline or non-crystalline in nature, and they're not very compressible. Makes sense, doesn't it? Because all the spheres are right up against with each other. I can't crush them together any closer because around each sphere were the electrons that are repelling each other. So I can't push them any further. They're kind of stuck there, not compressible. Okay. And they have what's called a high density. We kind of introduced this a little bit earlier, but that's okay. Here's the equation on the far right. The density is equal, right here, is equal to the mass. It's a ratio. Is equal to the mass of the material divided by the volume that it has. Okay? It's simply a ratio. We're going to have a lot to say about ratios down the road here. Okay? It is a mass over volume, just like your speed, miles per hour. Okay, that's a ratio, miles per hour. Your pay, if, you got a job and you're working out there, $50 per hour, okay? Or $5,000 per hour. That sounds pretty good, doesn't it? Okay. All right. So solids have a high density than their liquid state, okay? And solids tend to sink when they're in the solid state and they're going into their, as a solid, they tend to sink when they're into their liquid state. Unlike ice, on the other hand, which is water in the solid state, will float in liquid water for a different reason. We'll talk at length about that down the road. Okay.
I've got a question.
Sure, go ahead.
What do you mean, like they vibrate? Like, why does that happen?
Oh, okay. When we get to the point where we get to the bonds, let me draw something here real quick. Where is my? Okay. Now this is a little bit foreign at this point. Okay, but if I were to look at, say, we're familiar with methane gas. Well, methane has this structure here, and I know this is foreign at this point, but I'm trying to draw a three-dimensional picture of methane. Methane, and we're drawing in the general form, will be carbon and 4 hydrogens. Okay, we got carbon bonded to 4 hydrogens. So carbon is the central atom, and then we had these 4 hydrogens bonded around the central atom. Okay, now three-dimensionally, this is what this image I just drew is trying to depict. These 2 hydrogens here and here are on the plane of the white. This here, the one up front, I kind of drew in a wedge. It's kind of, you got to think 3-dimensional. It's coming out of the white plane, and then the one in the back is going to the back. Okay, so this is an attempt to draw a 3-dimensional picture in the 2-dimensional world that we're living in right now, but it's 3-dimensional. What is happening is, let me change the color here, is between each bond, I'm going to draw in yellow, between the carbon and hydrogen, there is a stretching going on back and forth, back and forth, back and forth. Okay, there's a movement going on between the carbon and hydrogen that's happening to all 4 of them. Also, the bond angle between these guys are bending back and forth, because these electrons are repelling. Keep in mind that everything in here in the lines that I drew are electrons we have a negative charge. And so there's a lot of movement going on. And so there's either the bonds are twisting back and forth to each other, or they're stretching back and forth like a yo-yo, if you will. Okay. The result is that this molecule at here in the atmosphere is vibrating. Okay. Only until we get down to absolute 0, which is like negative 273 degrees Celsius, that this matter supposedly, theoretically, stops completely. So the bonds are not moving. There's no rotation, anything going on. They completely stop. But we haven't reached that stage yet. And so in everything above that, the bonds are constantly moving and vibrating. So even though they're packed with each other tightly, like so, this represents solids, okay? There's still vibration going on in each atom. Okay, if that makes sense to you, because of the vibration going on within the bonds. And maybe this will be clearer once we learn more about the type of bonds that we're going to talk about all these bonds here that I just mentioned here. I'm jumping way ahead, but for right now, they're moving. The bonds are moving, and hence you get vibration. Okay, does that kind of make it clear at this point?
Yeah, that makes sense.
At this point, and once we get into the individual bonds and I get more into electrons, it hopefully become clear. But matter moves constantly until it reaches absolute zero. Now we've been close to absolute zero, but we haven't been that close yet. We got real close, but we're having trouble getting at absolute zero. And the cool thing about getting down to that low temperature, there's a whole new science down there, a whole new thing happening, which is pretty amazing. Anyway, back to density. As I mentioned before, density is nothing more than the ratio of mass over volume. You have density. You can calculate your density. If you measure your mass / weight and you measure your volume, okay, you might say, well, how do I get my volume? Well, I'll tell you what, if you got a jacuzzi and you know the volume of that jacuzzi, okay, and if you know, if I put something in if I put myself in the jacuzzi, completely immerse myself, that water level goes up, right? Because I displaced that liquid, all right? So if I had a way to measure that volume of displacement, I can measure my whole volume by immersing myself completely in that bathtub or jacuzzi and somebody measuring that distance that it went from where it started to where it ended up. And that is my volume. I know my mass. Now I can calculate my density. So I take my weight divided by the volume, I got my density. All matter has density, okay? It's simply a mathematical ratio. Solids do not mix by diffusion or osmosis. Why? Because they're locked in position. They're locked in this, and they don't move as freely as something in the liquid phase. Okay, some properties of liquids. Well, liquids, again, you should hopefully know this, take the shape of the container, right? But they have constant volume. So if I have a gallon of milk and I put in a gallon dispenser, and I take that gallon and I move it over to a big old container, I still have a gallon of milk, but its shape is now different than it was in the gallon container, right? Because of the new shape it got in, I placed it in, but it's still 1 gallon. So I have constant volume, but it takes the shape of whatever container I put it in, okay? Different liquids flow at different rates. Makes sense. Like the example I said earlier about honey and water, you get that race. You got a cup of water, a cup of honey, I flip them. Well, obviously the water's going to win. Okay. And that is because the intermolecular forces of the water are much less than the intermolecular forces of the honey. Okay. So the honey molecules are holding on to each other simply because of the electrons around the molecules of the honey, and they're holding on to each other, so they're going to have a higher viscosity. Now, how can I make honey run quicker? Anybody have an idea? I got a cup of honey. I want to get it emptied in that cup a lot quicker. What could I do? What could you do to that honey to make it flow better, quicker? Anybody have an idea? Let me see. Yeah. Exactly. You heat it up. Everybody's right. You heat it up. And what are you doing? By heating it up, you're breaking up that interaction of the molecules of the honey. You're breaking up this IMF, intermolecular forces. Okay. You got a whole chapter on that. We have a lot to say about that at length. And liquids, they're not as compressible, okay, because recall the diagram of liquids. They're not as ordered as the solid, but they're still real close to each other. And so you can't put them together anymore. You can't compress them. They're pretty close to each other already. There'd be a little bit of compressibility, but not a lot, which is a good thing, because without that, we wouldn't have power steering, power brakes, hydraulics. Yeah. All right. Liquids have a much higher density than gases, that ratio of mass over volume. And soluble liquids will mix uniformly together. Soluble, keyword soluble. Okay, so if I have a mixed drink, for example, alcohol and water, they mix. They're soluble in each other, so they will mix uniformly. But if I have Italian dressing, they're not going to mix because I got oil and water. They don't mix, again, due to the properties of the liquids. Now, with respect to gases, gases have no shape. They take on the shape of the container, just like liquids, okay? And they expand and compress much more readily than solids and liquids. And simply, if you think about it, recalling that diagram, why? Look at that space between how we depicted the gases. They're far apart from each other. So they have compressibility. They can come in closer together much more than the solids or the liquids, okay? Volume increases as atoms get further apart. Okay, makes sense. And volume decreases as the atoms get closer together. Okay, now they don't have a set volume. Okay. There's only one condition, which we're going to learn down the road, that there is a specific volume for gases. But at this state, at this point right now in the semester, gases have no set volume. Okay, and they have very low densities, very low. Okay. They tend to mix completely with other gases. Air, a good example is the air around us is a mixture of nitrogen, oxygen, carbon dioxide, and a bunch of other gases around us. Okay, they mix very readily. And gases exert pressure because they're hitting alongside of the container, of whatever container it is. I mean, just take the pressure of your tire in your car. You get 32 PSI. All you got in there is gases, but they exert pressure. You got 32 PSI. And if your tires get low, what do? You put more gas into it, pressure goes up, right? All right, so this table kind of puts it all together. It says, has a fixed shape for solids? Yes, okay. And they have a fixed volume for solids. With respect to liquids, no fixed shape, okay. You take the shape of the container, but they do have a fixed volume. Now with gases, it's no all the way around. No fixed shape, no fixed volume. Only under one set of certain conditions, which we will learn about down the road. Okay, now with respect to physical and chemical properties. Now, physical properties describe the appearance of the chemical, things about the chemical. It could be the color, whatever color that chemical is. It could be the odor. Some things smell real good, some things not so good. Okay. There's a class of compounds called ester. If you like wintergreen, they smell pretty good. They're esters. If you have gas at home to supply your heat, they put a little bit of what's called a sulfur-based compound. Those things smell bad, okay? Because they want to make sure and there's a gas leak, you smell that there's a leak. So odor, taste, I wouldn't recommend tasting anything, but we do taste them. A lot of the foods, think about this, a lot of foods we eat are chemicals. Everything. You put something on your french fry, sodium chloride, that's a chemical, all right? Sodium chloride enhances the flavor of things. Things like melting point. At what temperature, when you heat this chemical, does it start to melt? For example, butter. You take the butter out of the refrigerator, it's frozen, you let it sit in the countertop for a little bit, guess what? It starts to melt. It's a low boiling point. The same is true with the ice cube. 0 degrees, anything above that, it starts to melt. All right, so the physical state, we denote those physical states as with the letters right here. Oh, go down. We denote them with the letters S, L, and G, meaning solid, liquid, or gas. Okay, and lowercase. Other physical states are the density, the ratio of mass over volume, whether it is soluble in water or in non-water solids. Okay, whether it conducts electricity, that would be a physical property. Copper is a metal, conducts electricity. Okay, something like glass does not. It's a non-conductor. The hardness of material is also a physical property. Okay. Now, with respect to chemical properties, Now, here's the big thing about the thing to keep separated. When it comes to physical properties, okay, this is important. When it goes from a solid to a liquid, chemically, it remains the same. So we all know that water, or we all heard H2O, right? 2 hydrogens and 1 oxygen. That is the chemical formula for water. But we know we have ice, okay? Liquid and gas. Well, structurally, when I have an ice cube and I heat it up and make it into water, liquid water, it's still H2O. I didn't change the structure whatsoever. And if I continue to heat that water to cause it to go into steam, which is gas phase, it is still H2O. So when it comes to physical changes, the chemical composition does not change. The chemical composition does not change. The physical composition changes. It goes solid, liquid, or gas, okay? When it comes to chemical changes, there is a complete change in the chemical structure, okay? Complete change. And so chemical properties, whether something is explosive, you know, TNT, dinitrotoluene or dynamite, very explosive. And when it ignites and blows up, it creates a whole new compound, okay? Whether something is corrosive, whether it's toxic, poisonous, those are chemical properties. Or you can get something that's inert, like gold. Gold, for the most part, is inert, meaning that it's not very reactive. Can I get gold to react? Yes, but it takes very aggressive chemical conditions to get it to react. And that's why gold is called a noble metal, because gold is still as shiny. If it's buried 10,000 years ago and you unearth it today, it's still as shiny. Yeah, it's a little dirty, but you buff it up, it's still shiny as the day you buried it, because it's so unreactive, okay? So things like rust, if something rusts or oxidizes or even breaks down, these are all chemical properties of a compound. And the thing is about chemical properties is that they will change the structure completely. For example, I can take good old-fashioned water and I can have it undergo electrolysis. I hit it with a big old jolt of electricity, and guess what? I break it up into its atoms that it was made from. I can break it up into hydrogen gas and oxygen gas. I have totally broken it up. I broke up H2O that has a certain structure and made 2 completely different components, hydrogen gas and oxygen. That is a chemical process, chemical reaction. Okay. All right. Now, we have names, and some of these you're familiar with physical changes. That's going from one state to the other. For example, going from a solid to the liquid, right? Melting. We're all familiar with that, right? Going from a solid to a liquid. If you go from a liquid to a gas, you are boiling it, you are vaporizing it, or it's evaporating. Okay, those are the terms used to describe a liquid going from the liquid phase into the gas phase. And a gas going to a liquid, we call it condensation. Okay? You got a nice cold glass of whatever you're drinking, water, right? You put it out here, it's a nice humid day, what happens to the outside? It gets condensed. Well, where's that water coming from? Where's that condensation coming from? Okay. Anybody know where that condensation is coming from? From the outside of and the outside of an ice cold container of some liquid? Where's it coming from? Where'd that water come from? Magic, right? Some Harry Potter. No, not diffusion. It comes from the air, exactly, Eduardo. All around us is water vapor. Obviously, we live in Arizona. It's not as humid, right? Yes, we have humid days, but trust me, I've been in humid communities and this is not humid at all. I was stationed in Louisiana, down in Arizona, boy, down in Arizona, in Louisiana. That was some vicious humidity. But in the air around us are water molecules, okay? And they have high energy. It's about energy. These water molecules come along, they just bounce around minding their own business, and then they hit your container, which happens to be cold. That energy that water molecule had is transferred to the container. And that water molecule now loses some of that high energy it had. And other molecules, water molecules, do the same thing. And by releasing that energy, getting rid of the energy, they come together. And then those intermolecular forces take over and they condense, and voila, magically you got water on the outside of your container. It's just called condensing. You're removing energy. How do I get that water molecules back into the atmosphere? Guess what? I put more energy into it. Boil it. Okay. All right. Liquid to solid. Freezing. So we got a liquid, you got ice cubes. Well, now you got ice cube machine, but back in the day you had an ice cube holder, right? Maybe you still have it. Put water in it, liquid water, stick it in the freezer. Okay. What you're doing is removing energy from that liquid water, causing those water molecules to come together and get more uniform, more organized. Okay. And you have solid. Now, this one you may not be familiar with. We have a solid that goes into gas. We call that sublimation. And I know you're familiar with this one. You ever play with dry ice? Dry ice, AKA carbon dioxide. Dry ice is nothing more than solid carbon dioxide. You can go to Fry's and buy yourself some dry ice. And you'll see it where it goes from a solid right into the liquid, into the gas phase, excuse me, okay? It's called directly. Does it go to the liquid phase? Well, if it does, it happens very quickly. It doesn't hang out there very long. It just speeds right through it. So to us, it looks like it goes right through the gas phase. And it's nothing more than carbon dioxide, okay? So those of you who have plants at home, if you take some dry ice and put it around your plants, not on your plants, but put it around your plants will be happy because it's carbon dioxide and plants get along very well. Or you can talk to your plants. Why would you talk to your plants? Other than the psychological aspects of it, what benefit would you have for talking to the plants? Based on what I just told you about dry ice. Exactly, very good. Because one of the gases that we exert is carbon dioxide. And so by talking to your plants, they pick up the carbon dioxide, they're happy, and then they make you happy because they exhale oxygen. And so it's a win-win situation. But if you don't want to talk to them, then put some dry ice on them, around them, not on them, because it gets cold. If you take that same gas and another example of sublimation is mothballs. You may be familiar with mothballs. They're look like little, I don't know, kind of chemical smelling material. It's a chemical called naphthalene, but they're good for killing bugs in your closet or something. And it's still out there. Some people still use them, but that goes from a solid to a gas sublimation. And then the opposite is you take carbon dioxide gas and you run it through this instrument and you create dry ice, okay, which is carbon dioxide solid. And that is called deposition, okay? So those are probably the two that you may or may not be familiar with. And so we have melting, boiling, vaporizing, evaporating, condensation, freezing, sublimation, and deposition. Okay, so physical changes. As I mentioned earlier, physical changes, nothing happens to the chemical structure. Now, we're a little bit early in the game here, okay? But that's okay. But I hope you can observe and deduce from the formula. Now, generally, when we write a process, be it a physical process, be it a chemical process, we write it as follows. We have what we call the reactants, okay? Then we draw an arrow, and then we have the products, okay? This is either be a physical process or a chemical process. The arrow going in one direction tells us it's a one-way road, one-way street. Boom, the reactant, something happens to it, now you created products, okay? Now you could do a chemical process where you change the structure completely, or it could be simply a physical process, like the example up here, where you have H2O, okay, which is water, okay. Here's something, when we get into dihydrogen monoxide, you get a chance once you Google that, you're going to be surprised at the stuff that's out there. Dihydrogen monoxide is the scientific name for water, okay? And you'll find all kinds of bad things written about it. Dihydrogen monoxide. Yes, water can be bad if you can't swim. It's not a good thing. But it just gives you an idea of how names are taken in out of context. Sounds terrible, dihydrogen monoxide. All right, so we have reactants go into products. Now we have one-way arrows, but heads up, sometimes we have a double arrow, meaning that this reaction goes in the forward direction and in the backward direction. But for right now, we're going to have one-way arrows. So what we have here is H2O, and in parentheses, we have the physical state, which is L, which is liquid. We have the arrow saying something's happening to it. And then we look over to the product side and we still have H2O. The fact that the formula did not change, okay, I repeat, the fact that the formula did not change before and after should tell you I got a physical change, no questions asked. And then to verify that, guess what? It's a gas. So it went from a liquid to a gas, okay? So this chemical reaction, this process, I don't want to say chemical, this process is a physical change, okay? Unlike, let's say, the one I used before where I had water going to generate H2O, hydrogen plus oxygen, the fact that I get a plus here, symbol, tells me, oh, I got two products. Oh my goodness, something happened here. I got water and I broke it up to make two products. So this tells me I got a chemical process because I created two products from one product, okay? And we're going to have examples at this point where you have these chemical reactions. And yes, I know that you don't know what they are, but I do know that you can observe and say, okay, I got H2O as the reactive side, and I got H2O on the product side. I conclude that I have a physical change because nothing happened chemically. If something happened chemically, then I wouldn't have H2O on both sides. I would have something else. Okay? All right. So overall, what we just talked about with respect to the changes is this flow chart here. You can see sublimation going on the far right, on the top side, deposition on the bottom side, okay? Now we got solid going to liquid is melting, continue to heat it up, you got boiling, okay? Again, you see the diagrams there. For whatever this material, we're not stating here that it's a specifically chemical, it is something. But you can see here that even if this wasn't there, you can deduce that you have a solid form because of the ordered state of the spheres. And over here, you could deduce that you have a liquid phase if this was written, because though they're ordered, they're still loosely bound. They're all moving around. And then over here, you can see it's got to be a gas phase because there's so much distance between the material. Now, as we put energy into the system, it's all about energy. Put energy into the system, we get ice melted into liquid. We continue to put energy into the system. We're boiling water to make spaghetti, right? Heating it up, putting more energy into the water. Guess what? Now we've got vapor. We're in the vapor phase. Now to reverse it, we take the energy out. If we have a gas phase like the condensation, the example, we got water vapor out here in the atmosphere. Take the energy away from it, it condenses, we're back in the liquid phase. You continue to remove energy, drop the temperature, and now into the solid phase. It's all about energy, putting in and taking it out, and it's all about breaking up that interaction between the molecules, okay? And those interaction between the spheres, they could be very strong or they can be very weak. These are these intermolecular forces, which are governed by these crazy electrons again, crazy electrons. All right, so let us continue. Oh, you know what? We got carried away here. I just realized the time. Yeah, sometimes I get a little carried away, so just send me a little chat, say, hey, Dr. Fred, I got to go home. All right, so we are in chapter 1, and we will continue with, what slide are we on? 19. Okay, we'll probably knock this out for sure on Thursday, and probably definitely get into number 2, chapter 2. This is kind of an introduction about chemistry, some basic concepts. And then what we do is we kind of go back into mathematics. We used to enter the mathematics first, and it kind of freaked people out. Like, whoa, this is way too early. So we kind of got the chemistry part, kind of introduction going on. We're going to get into converting factors and numbers and do some calculations, because we're going to use this technique down the road when we do calculations. And then we go back to chemistry, okay? So anyway, let us stop.